Hi everyone, Harsh this side. I hope all of you are keeping great. So in today's video we are going to discuss a very interesting question. Find the nth node from the end of a linked list. So you have been given a linked list consisting of some nodes and you have to find nth node from the end of the linked list, right? So we're going to discuss the approach, algorithm as well as the coding part for this question. So let's get started. So let's understand the algorithm of the problem, right? Suppose you have been given a linked list consisting of 5 nodes 1, 2, 3, 4 and 5, and since this is the last node so it will definitely point to null, and you have been given a number n is equal to 2. So you have been asked to find nth node from the end, that is second node from the end of a linked list in this case. So if we count backwards, this is the last node, that is the first node from the end, and this is the second node from the end. So this should be our output, that is we should return the value 4, right? So the thing you have to keep in mind here is nth node from the end of a linked list is equivalent to total minus n plus 1th node from the start of the linked list, right? So in this case we can understand it by, since n is equal to 2, so second node from the end is 4, we have already seen this, right? And if we go by this right hand side, so total we have 1 2 3 4 5 nodes, so 5 minus n is 2 plus 1, so it gives 5 minus 1 gives fourth node from the starting, 1 2 3 and fourth node from the starting. So in either case we arrive at the same destination, right? 4. So this is a very important thing to keep in mind. Nth node from the end is equivalent to total minus n plus 1th node from the start, right? Now what's the way that we are going to apply to solve this kind of a question, right? So this was our original linked list, 1 2 3 4 5, finally a null, right? So we are going to use the concept of two pointers here, right? So we'll initialize two pointers, one will call as the current node and one will call as the nth node, right? And at the start we'll initialize both of them to the head of the linked list. This is the head, the starting node of the linked list, and we'll initialize both the pointers, current node as well as the nth node, to the head of the linked list, right? Now what we will do, this current node pointer, it will keep moving forward till the value of n becomes 0, right? So basically we'll put n into a loop and keep decrementing n every time till it does not become 0, and at every step we will keep incrementing the count node pointer, right? So in this case, since n is 2, so this loop will run 2 times, so count node pointer will be incremented 2 times. So at first step it will come here, and in the second step this will be the updated position of current node pointer, right? So we can just update this. After the loop gets finished, this is the position of current node pointer and this is the position of nth node pointer. So the difference in positions of these two pointers is already equal to n, right? Because if you start from this node, you'll have to go forward n nodes, that is 1 2, n is equal to 2 in this case, right? So the difference in the position of these two pointers, the nth node pointer as well as the current node pointer, is n in this case, which we have achieved, right? Now what we will do, now we will run a loop, we'll again run a loop till this pointer, current node pointer does not become equal to null. That is, we'll run a loop till this pointer, current node, reaches this null, and during the operations of this loop, at every step we will increase and or update the value of both the pointers by 1. That is, we will move both pointers forward by 1 step. So as this loop starts, current node pointer comes to 4, nth node pointer comes to 2. In next step, current node pointer comes to 5 and nth node pointer comes to 3. In next step, current node pointer comes to null and nth node pointer comes to 4. But since now current node pointer has arrived at null position, so this loop will terminate, and since the loop has terminated, we'll just check that the place or the position where our nth node pointer has reached, it should not be equal to null, and if it is not equal to null, we will just return the data of this position, right? So we can see that when n was equal to 2, so we needed to return second node from the end of a linked list, which was 4 in this case, and this 4 has been returned, that is at the position wherever the nth node pointer reaches finally. So that position will give you the nth node from the end of a linked list. So this was all about the algorithm of the problem. Now let's come to the coding part of this question. So at first we'll have to create a structure of node, right? So class node, a data variable, and next pointer has to be included. Now we have to create a constructor and we have to initialize data equal to d and next equal to null. So this is pretty much obvious, all of you might be knowing this, it's a very basic concept. Now comes the actual part. So class calc public static. Now what has to be the return type of this function? See, you have to return the nth node from the end of a linked list, right? So basically you have to return the value of that node, right? And that node might be holding some number, and numbers are of integer type. So int has to be the return type of this function, int, and you can give it any name. So x, I am giving the name of the function, right? And it will accept a head node as well as the value of n, that is nth node, because we want to calculate from the end of a linked list, right? So now, as we discussed in the algorithm, we'll create two pointers, a current node, and we will initialize it to head, as well as we'll create a pointer nth node and we will also initialize it to the head pointer, right? So now we will run a loop till the value of n does not become equal to 0, right? We will check if the current node has reached null. It means that we have not been able to find the specified node, right? The linked list has already finished, so this is a wrong case. So we will return -1. That is, we didn't find a node, so we cannot return its value, hence we return -1, right? Otherwise, we just update current node with the next of current node, right? And yes, we decrement the value of n, because this loop has to go till n operations, right? So after the end of this loop, the current node pointer as well as the nth node pointer, they will be separated by a distance of n nodes, as we saw in the example, right? So now what we'll do, we will run another loop, while loop, till, and what has to be the condition inside it, while the current node does not reach null, that is the end of the linked list, and till the time it does not reach the end of the linked list, we will update both pointers. Nth node pointer becomes the next of nth node pointer, and current node pointer becomes the next of current node pointer. And our task is pretty much finished by now. See, basically the concept behind this is, we have used two pointers to solve this problem, right? Nth node pointer as well as the current node pointer. So we have to move second and first pointer simultaneously in this loop till the first pointer becomes null. This is the first pointer, right? Because at this point the second pointer will be at the desired node, that is by the time this pointer has reached null. So at this point of time this second pointer will be at the desired node, that is the nth node from the end of the linked list. And why so? Because the first pointer, that is this current pointer, had already traversed n elements previously in the previous loop, and thus we had a difference of n nodes between the first pointer and the second pointer, which we saw above, right? So after this loop gets finished, we just have to check that if the nth node is not equal to null, so we return its data, nth node data. And if nth node was equal to null, else we return -1. So this was the entire question, talking about the time and space complexities of this problem. See, there are let's suppose there are n nodes in the linked list, or let's not say n, let's say a nodes in the linked list, because n we have already taken, right? So the time we will have to traverse all the nodes of the linked list at least once, right? So the time becomes of the order of a, where a is the number of nodes, right? Number of nodes in the linked list. And the space complexity, space is pretty much a constant factor, because we haven't used any extra space apart from what's needed in the question, right? We have not created any array, we have not created any stack, it's just the linked list which we have used, right? The nodes of the linked list. Hence space is a constant of order of 1. So yeah, this was pretty much about it. So that was all about the question of finding the nth node from the end of a linked list. I hope all of you might have got the concept of doing that problem by now. So take care, we'll meet very soon. Happy coding.